Okay, let's... Okay, let's... Hey. Okay, let's... Okay, so I wanted to copy my Livestream YouTube widget. Normally I put these Livestream YouTube widget. That's not the normal YouTube. Okay. So, well, let's go ahead and I want to start by we're going to go to my website. We're going to go to the App Store. There's pretty much only one, Frot's Text Adventure. Okay, we're going to download this. I think we say, I don't know how this works. I don't use Git. We want an ISO. How about that? We probably want a README. Okay, so click on this. Download. We're going to save it. 1.2 meg. Wow, that's big. Bigger than I expected. Okay. So now we're going to shut down. Now we're going to go, we want to mount that ISO file. So we have to shut down, file, mount virtual disk. And no, that's not what we're doing. What am I doing? Wrong answer. Okay. We do edit virtual machine. We pick ISO image. We go to downloads. Demo ISO is in my downloads directory. So I'm setting the CD-ROM to point to the ISO. Now we're going to start up. So at this point, CD-ROMs are kind of tricky. Normally you don't mess with them if you're using VMware, although it should become a very common thing. So basically, who knows which one is the correct one? Just try all the drives until you find one that works, and if that doesn't work, you mount and create a new drive. It's so let me explain what's happening here. In VMware, you have a hard disk and a CD-ROM, and if you go to the advanced, these are IDE. There's 1 0, but if you can change this. 0 0 0 1 1 0 0. Okay, so what we would like is hard disk 00, CD-ROM 10. As a matter of fact, VMware plays musical chairs. If you create a setup, it's going to move them around for no fucking reason other than to be evil. I think it's the CIA motherfuckers. Okay, anyway, so in a perfect world, they would stick hard disk on, oh, look at that shit. See that? Hard disk 1.1, motherfuckers. The fuck did you do that for? Okay, so the CD-ROM, I didn't mean to move it. Did I move it? 1.0. Okay, 1.1 and 1.0 is on real hardware. They interfere with each other. If on real hardware, these two interfere with each other. Oh, look at that! It says CD and hard disk. On real hardware, you don't want them on the same controller. I don't think. I've never done performance analysis, but they have to share the controller. That doesn't sound good. So VMware, little motherfuckers, play musical chairs for no goddamn reason other than to fuck operating system developers. Those CIA fuckers. Okay, they fucked up my sound because that's the only... I'm not joking. I can't do my hems because look at this shit. Okay, so we could go through... So what am I supposed to do? I'm supposed to detect which one's the hard disk and which one's the CD-ROM. Okay. So let's pretend we want to do it correctly. This is not really the answer. Okay, so in Linux, ls PCI minus v. So in Linux, this is for for real hardware. If you do ls PCI, these are the PCI devices, and you will see, I don't think I'm scrolling. You will see SATA and then some port numbers. Okay, so 4 ports, a block of 8 ports, a block of 4 ports, a block of 8 ports, a block of 4 ports, a block of 32 ports. Okay, so so that looks like the only... Now here's another SATA. Here's SATA. Here's some other address, some other ports. So an I/O port is a 4-digit hex number. Okay, and so in order to use a hard disk or a CD-ROM, all you need are the ports. And then what you do, I'll teach you how to do this. You tell it, okay, I want to select a block, and then okay, the disk is made of disk blocks. Okay, so if you do dir star true, this tells the disk clusters, and you can dump cluster 0x. Okay, so we're going to dump a cluster. Let's dump the directory. So this is going to be a FAT32 directory cluster. It's not a pretty sight. So these are where the file names are stored. Now, this started for DOS, and then they expanded it. So what they started doing was putting together multiple entries, long and short, and they have part of the file name in one spot, a little bit more in another spot. It's a mess. So we're commanding them to support Red C so that I can get rid of this. But anyway, so disks are made of blocks. If you put 20 blocks together, you get a cluster. It depends on the size of your drive. Basically, a disk block is 200, and it looks like we have FFFF. Looks like we have so 8 blocks of 200 make up a cluster. So anyway, on this drive of this size, if you want to see how that works, you can look at format. And I didn't do this is the word canonical? I don't know. So when you're formatting your FAT partition, then depending on your file size, you give it different number of sectors per cluster. A sector is another name for a block. You have blocks and sectors. So how do we? So there's I/O ports, which are the that's what you're in and out, and so there was a block of 8 ports, a block of 6, a block of 4, and a block of 32. So what is that all about? So for a hard disk, the protocol is called ATA. I don't know, attachment something, I don't know. And there's a block of 8 registers that are offset from the first base, and there's another base. The way I do it is kind of weird. So the first step is to figure out what ports your drive is using. Okay, the little motherfuckers at VMware decided to play musical chairs just to be fuckheads. So in the old days, there were, you remember it was 01, 0000110. There were 4 of them. Well, sometimes they call that primary IDE unit master unit slave, secondary IDE unit master unit slave. Okay, and that's how it all started in the simple old days. And those started with some default numbers. For each drive, for some reason, they had to break the ports into 2 pieces. There's 8 ports on the first number and 1 port on the second. And anyway, so for some reason, they broke them into pieces. I hope to perfect all of this in the future. We're going to redo everything. We're going to fix the hardware. Anyway, so right now they've cluster fucked it and then double cluster fucked it. So in the old days, you had fixed locations, 4 of them. Master and slave, master and slave. Master 0, slave 1, master 0, slave 2. So what did they do? They made PCI, which was the big improvement. And what did they do? Well, how do you find where your they still kept, okay, first let's look at ATA spec. So this is what I got from Linux. I looked at Linux and I got the same. This is the correct documentation. It's publicly available. The little niggers like to torment me because I got this information from Linux originally. Now I have the official source. Fuckers. Little CIA. They want to squash any new operating systems, and they clusterfuck Linux so nobody can understand it. They don't want direct block access. Why? Well, fuck them. There's something, we have a right to guns. Fuck it, we have a right to block access. God said we have an ancestral right, that this Commodore 64 is our ancestral lands. And what that means is, for one thing, we can read and write disk blocks. So let's find out where this is. So let's start at the index and look up the commands. So let's say we want to read we want to do a block read. Okay, so how do we do it? So we come in here. I'll give you a hint. Read single block does not work. Okay, on the drives I've tried, you have to do read multiple blocks. Now in the original days, there were they started with one size and then they expanded it, and that's the expansion size. So as a matter of fact, there was even a version before this, which was really awful. Sector CHS this is 28-bit. Okay, the first one was CHS. If you see CHS, that's garbage. It's ancient, really ancient. The next one was the 28-bit. They call it LBA, logical block address. So in the old days, you had to worry about how the drive was laid out into sectors and clusters. And then once they got a little better hardware, once they could splurge and make it a little easier, they made the drive calculate its own blocks, and the blocks were just numbered from 0 to FF something. Okay, so that was 28 bits, and then they expanded it up to 48 bits. So let's go look at the only one you need. Someday I'm going to get rid of. Okay, this is for less than 130 gig. So we're up in the terabytes. So back when drives were 10 times smaller than a terabyte, we hit the limit. So it's been a while since we hit the limit. Anyway, so 191. I do in fact check for the old ones, but it's not a big deal. Okay, 191. Now I'd be curious to know. Now the FAT file system has a limit. I'm not very. I forgot what it is, but it's kind of tricky because they have that sectors per cluster. We can look into that. Well, I forgot. I spaced out. Was it 191? I can't remember. I forgot. 191. So we're going to look at how you read a disk block. Let's write a little program to do it. Brute force. So it's our fucking ancestral land. It's a goddamn ring 0 only operating system. So if we want to read our own fucking disk block, we can read the motherfucker. Okay, so real men like being on raw hardware. Is this what it was? Read multiple extended. Okay, so the extended is 48-bit LBA. So what is this telling us? This is telling us what the registers are used for in this command. And what you have to do, here's my, okay, so once you figure out where the registers are, there's a block of 8 and then a spare, and then a second one. Once you figure out where the registers are, then what you do is you start, these are bit fields. I make an array. Once I have this is the count, and I'm taking, I have all of my integers are, start with, my integers are I8, I16, I32. My unsigned integers are U8, U16, U32. So what this designation means is we started with a block that was a 64-bit signed, and when we see this block U8, now we're getting into the bytes that make up that integer. And this is the third byte over. So in other words, maybe this is 1, 1, 2, 2, 3, 3, 4, 4, 5, 6. So this is some number, 0x like this. And what all we're doing is we're taking, this is U80, this is U81, this is U82, this is U83, this is U84, this is U85, this is U86. Okay, so what I've done is I've made a way to access the bytes. So this is telling us where they're stored, so we can confirm that the lowest 8 bits are in, these are the bits. This is a fairly standard industry in data sheets. These are the bits, and that's not really showing us anything. And why did the motherfuckers? Okay, they named the registers, that feature register sector count LBA. Okay, so as a matter of fact, I named my registers, and sector count. Okay, sector number. Okay, it's sector gets the third byte of the block, so that should be 24 to 31. Oh shit, wait a minute. What? N sector is sector. Sector is something else. There's 2 of them. N sector is number sectors. Count. N sector gets the high byte of the count. Okay, now the way the 48 and 60, the way the 48 and 28 work is, first they write to, they write to the registers twice. So N sect, L cylinder, high cylinder. Then they start over, N sect, L cylinder, high cylinder, and then they hit this select. That happens to, remember I said there's 8 together and then 1 apart? I'm pretty sure the select is the 1 apart. No, that's not. I lied. I think in my designation there it is. The 1 here means it's the other bank, the other bank of registers. Okay, so sector. Look, let's. No, maybe we should rename these. Well, you want to rename them? You got anything better to do? Okay. So for other commands, what's... Okay, so LBA low. So this is back from when it was cylinder sector head. The head used to go, well, anyway, I think we've pretty much explained it. That's getting, the head used to go in, they had some 4 bits, and they had some more bits there. Now they clean that up. And then this is master slave is the unit, and you got a crazy number here. I remember I had a bug one time where I had that number wrong. That is the select. I think it's this one right here, device. OBS LBA. Okay, so hold on a second here. This is the output. You know what? Okay, so the HOB, I think that's the one in the control. I do believe. Device control register is the HOB. Holy shit. Wait a minute. This is on the, this is for reading the output. So I think on, hold on a second. What? Notice they don't have the HOB. Why didn't they do it like a white man? Fucking do the HOB instead of this fucking... Okay. Okay, so why did they have a separate bank? Little motherfuckers. Oh, fuck. Okay. So I think if we look at the read native, is that where it comes from? Or is that off of a block? There's 2 ways you can get data. You can read the registers, or you can get a block. There's an information block, but I do believe when you fire up, when you reset the drive, you read the native size. Do you get it from the registers? Read native max. I think the HOB. Yeah, here's the HOB thing. You set control 80, and then we're reading the size of the drive, and we're reading the low size, and then we're reading the high size. And why didn't I set it to 0? I was really a skin flint. Is that the word? So when I did the previous command, I left it set. The control, oh, there it is. Control 8. Okay, well, anyway. So that's, you have to get the size of the drive. Now, okay, so now the modern interface is PCI. Okay, let's take a little peek. First of all, what I want is I want it to work for everybody. And I don't know how much variation there is. I think I do the best possible job of getting it to work for everybody. Hello? 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 Okay, so, never mind. So, here's the deal. Some people look at the Linux code. I looked at... Hello? Hello? It is? Okay, thanks. Okay, bye. What? My stream is broken? My stream is broken? My stream is broken? Okay, fuck it. So the CIA is censoring me. Is that what's happening? So, how long was it broken? My stream was broken. When? What did you hear? Oh. How long was it broken? My stream was broken. When? What did you hear? Oh. How long was it broken? My stream was broken. When? What did you hear? Oh. How long was it? Fuck. Okay. Okay. Oh, let's see. So, let's see if we can get this bigger. No, okay. Okay. Fucking. My stream is broken. Isn't that fucked? Hey, it's not. The fuck? It's not full screen. That's what I normally do. Oh, never mind. Okay, space now. So, I hate when that happens. Got interrupted. Stream is motherfucker. Fuck you. How much did you miss? Are they gonna censor me or some shit? Fucking CIA. So, fuck them, man. So, get God to fucking kill some CIA niggers. So, to figure out so let me give you an overview of the documentation. There's architecture manuals from Intel that cover the x86 2A and 2B are all the opcodes, and they sort of explain. 3A and 3B are 3A is the one I had to look at. 3B is for if you want to make a program like VMware. It's a whole new story. So I haven't even looked at that. If I wanted to make VMware, so this is what I looked at. So this tells you what you need for the operating system. Then it gets kind of confusing once you start dealing with hardware devices. If it's processor related, it's in here, but once you start getting into I/O, now you're dealing with these ICH chips. These are support chips. I'm not an expert on this shit. I'm kind of overwhelmed. But anyway, so there's every couple years, I think they make a new one. And I don't know who else makes them. But so ICH 10, when I had a Core i7, it had one of these. And so they make a new data sheet, but sometimes you have to go back to the earlier data sheets because they don't document stuff. You have to find it in the earlier ICH sheet. And so here's SATA. So this is serial ATA. They call it PATA. Well, nobody calls it that, but that's parallel ATA. The original hard drives had flat ribbon cables, and they had, I don't know how many, they had a bus. That means several wires for numbered 0, 1, 2, 3, 4, 5, 6, 7. So if you have an 8-bit bus, you have 8 wires numbered 0 to 7. And so the original IBM PC had PATA. It had a parallel ribbon cable. Now they have a serial cable. But that's mostly a hardware concern. it doesn't really affect the software. So they started I'm not an expert on these definitions, but you'll see IDE when you start looking at you'll see IDE and you'll see ATA. Okay, so IDE is that's what you'll see that word for early hard drives. But they all use ATA, which is the standard. Anyway, so like if you go back to one of these early ICH6, you'll see in here IDE controller, and basically they have the four. Okay, so this is a PCI. Now your eyes are gonna glaze over if I explain all this, but so the original PC had I/O ports and memory. They had I/O space and memory space, and now there's a couple other spaces. There's PCI registers. You have to know the device function. So PCI devices are designated with a device family, device bus, the bus with a bus device family? No, it is not right. Bus device function. That's what I meant. Okay, bus device function. That's the way they address. So all modern devices are PCI for the most part. It's really quite cluster fucked when you start getting into interrupts and stuff like that. It was supposed to be simpler. So now let's imagine you want to find out where the hard disk controller is. Okay, how hard can that be? They had to have done it like a white man, did they not? Okay, let's see. So we come in here and we want to find the I/O ports for the hard disk. So what they have are some BIOS routines. Okay, most people are familiar with the original BIOS, but there's this crazy new thing called PCI BIOS 32. Okay, so the original BIOS everyone knows about, but now they added some PCI support. So the way you interface with PCI devices, now you would think, okay, there's a category. So we want hard disk. So we tell it I want the address of the hard disk, and it's going to give us a bus device function. Okay, so how hard can this be? So we want the address of a hard disk. So PCI class code. So we want the class of a hard disk. Okay, let's look at how the lookup function works. So these are just subroutines. you pass it inputs and get the outputs. There's one for looking up the bus device function of a category. But it's not just a class, it's a subclass. And that's where it gets really clusterfucked. So where did it go? These are the subroutines that PCI BIOS supports. You remember I said there's an IO space, there's IO space, there's regular memory space. Well, there's PCI config space, and you access it through this library. Find PCI class code. Okay, how hard can it be? So we want to look at the subroutine for find PCI class code. Why don't I do a text search? Find PCI class code. This function returns the location of PCI device to have a specific class code. Given the class code and index, okay, maybe you want the first hard disk or the second hard disk, or 0 or 1. The function returns bus device function. That's how you address it, bus device function of the nth device. Okay, that sounds reasonable. So here's where it gets fucked. Class code in the lower 3 bytes. So this is a 24-bit index. Okay. Entry. 24. We want a 24-bit class code. And it exits bus function. Okay. So, you want to actually do this? Let's do a little example. We got nothing better to do. So let's go to PCI class codes. So this is where you go if you want to find out okay, so it's a hierarchy. The top class code is we want mass storage 01. And then we want, okay, they made our life difficult. There's IDE, ATA, SATA. We have to search all 3 if we're going to do this port IO. Now, the reason we want to do this is we want to find out the port number of the hard disk, the correct white man way. And that would be to call this class code thing and get the address. And then look into the config for the port numbers. That's how it should be done. But they clusterfucked it so that nobody can do that. Okay, so which is it? IDE, ATA. Well, I'll just go ahead and spare you some suspense, and we'll do a PCI rep. And this should okay, what do we have? So there's a I had to do some work to get these labels. Uh-oh. SCSI is a hard disk. That's the opposite of ATA. I don't know anything about SCSI, but it's not good. Okay, so I don't think I don't think it has anything to do with ATA. But if I'm using ATA, I don't think it's SCSI. So PCI bridge, AGP, is that graphics? Pentium R. Hello? So, long story short, if we go back to I can list the class code of all PCI devices, or we can go in. So, okay, this is. Hello? 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 Why? What's wrong? Okay. Okay, bye. Okay. Sorry, I didn't mean to do that. That's gonna. So, so this command I wrote lists all PCI devices. What we were investigating is how to find one specific one. So from the list, I forgot which one is the it could be unknown. I don't think so. So let's look for, oh, it's the mass storage. Let's go ahead and use some deduction. Number one is IDE. So there are two. This is the class code. So this one is SCSI. That's not what it is. And this one is. So I sort of cheated. So this is the class code 1 PCI bus master. Okay. So, IDE controller. There it is. It's right there in front of our face. So that's the IDE controller. So it's bus 0 function, bus 0 device 7 function 1. That's the address. It's a triple. And this is the class code and the subcode. So the subcode is 01. So you might think that's easy. What the fuck is this? And why do I care? So let's pretend we came to this web page and we said we want to find an IDE. Now you have to tell it a subcode. It's not allowed to say any subcode, as far as I know. So we come in here, we say, okay, remember it's a 24-bit, and so it's a 24-bit. The class code is 24-bit, and the highest bit is 01. that means mass storage. The next bit is 01, that means IDE. And the third bit, what the fuck is this? Okay, so this is garbage. So basically, you know what you have to do? I could be wrong, but I think you have to check all 256 of these. Unless you got a better idea. So when you're using the PCI BIOS, you have to check all 256, and you have to check SATA, IDE, and ATA. So you have to check 3 different categories. You have to check all 256 subcodes until you find something. Makes me angry. Okay, so now you have to call this function 256 times. This takes time. We're talking real. They talk about real money. Doing I/O port commands. We're talking some serious I/O time. This, I mean, I don't know how. I think it's to scan 256 of those ports, of those subcodes. So why are we doing this? We want to find the bus device function. Like, for example, in this I/O controller, it's, well, the bus is, I don't know, that's variable. Device 31 function 1. Once you have the bus device function, then these are supposed to be standardized. I have no way of knowing. For a lot of hardware, you have to actually own the hardware to write a driver. But maybe hard disks are pretty standard now. So once you have the bus device function, then you want to look at these. This is not imports. It's not imports. It's not memory. It's PCI config space, and the way you access it is with the PCI BIOS, and these are registers within, and so this is where you get the I/O ports. So we could do a scan to see. I don't know why I didn't list the third category, the subcode. Maybe it, I don't know. So no, we don't want to see that. Do a drive report. What we got from the PCI config space is either a 1F0 or a 170. This used to be just standard, and there were only two possible. There was IDE primary and IDE secondary, and then there was master and slave on both of them. But now they made so that the drives can be at any I/O port. And as a matter of fact, if you really wanted to make a native, native operation is not going to happen. And it used to be possible up to about 3 years ago. So ls PCI -v. So if you really wanted to make a native, you would have to find. Hello? Okay, bye. There's a troll in the chat. There's a troll in the chat. Troll in the chat. Hello? What the truck? Okay. So, you have to find the, so when I first did my operating system, I simply asked the user to enter the I/O port for the hard disk. That would require them to run an lspci command, look for SATA, and then do trial and error on... Hello? Hello? And then do trial and error to, you want two sets of ports, a block of 8 and then a single. And anyway, they kind of scramble them a little bit. But I tried to do it the correct way, and what that is first, so to do it the correct way, first you need to support the PCI BIOS. It's a 32-bit. It's kind of inconvenient to switch out of 64-bit mode, but you have to support the PCI BIOS, and then you have to start scanning those. Hello? Hello? Yeah. Yep, okay, bye. Okay, so okay, so so if you want to do it the right way, you use the PCI class code. Okay, 1.1 for mass storage IDE. Now you have to do this nigger gibberish. We have to go through all fucking 256 of those motherfuckers, scan for them. If we find one, we have to test it. That's not really kosher. You're not really supposed to. Hello? 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 Yeah. Okay. So okay, so you have to find. So it sounds really in my original operating system, I simply ask the port number for the hard disk and CD-ROM. Then I tried to do it automatically, and for the fucking CIA decided to play musical chairs. When you define just to be fucking dickheads, okay, the little motherfuckers. So when you go in and look at your hard disk, is it at 00? No. They randomly place it. And where is mine? 1.1. Okay. The little motherfuckers. So I think these Hello? Yeah. Okay. Okay, bye. Hello? Okay, bye. I thought I... Unblock user. I don't know. So, hello? 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 What? Okay, bye. Okay, enough of that. We've had enough. So I just wanted to point out that they deliberately clusterfucked the hardware, and I'm gonna, with the authority of God, fix everything. It gets worse and worse and worse the deeper you go. Hello? Well, there's no networking. I don't know what you're talking about. No, they could do that. Well, they can, if they can control Linux, and Linux can see into VMware, but VMware can't see out. So yeah, I think yeah, they, if they have control of your machine, they could see in. I don't care. Anyway, bye. Okay, so let's go back to what we're doing. Let's have some fun. So I set the much earlier today. Let's go ahead and do that. So if you go to here's what's going to happen. You're going to go to the App Store. You're going to go to Text Adventures. Then you're going to download an ISO, and this is how applications are going to be done. So we download it, and then once you download the application, you're going to set the CD-ROM to point to the ISO file, save it, and then you have to boot, and so the reason we got sidetracked into the discussion about the drives is because we want to access the CD-ROM, and there's 3 drives listed. It's kind of confused. That's because I got indications of other drives, and it's kind of fucked up. So anyway, if we say drive T, it's not finding it. Drive U, not finding it. Drive V, not finding it. Okay. I don't do this very often, but what we're gonna do, we're gonna mount drive T. I don't think we need to. We can probe. So basically, it's broken. the drives aren't working. We're going to come in here. It was drive, ATA is hard disk, and so it was from VMware. We can tell what it is. Let's go ahead and stop out of here. Let's go look at the drive to tell what it is. My thing is kind of fucked up. So it was able to, okay, it's the CD-ROM is 10. So what that is so the CD-ROM is drive 10. I happen to know 1 is 170 and 10. This, so it should be U, but it's not working. Okay, I don't know why. We're gonna define a new drive. What the heck, on top of U, and we're gonna probe, and these are reversed. 170 is secondary, 1F is primary, and so it was 10. So that's, long story short, it's number 3. Okay, now if I say drive, let's cross your fingers. Okay. So this is the ISO file. This is a CD-ROM. Basically, we just mounted a CD-ROM that we got off of a website, and this is how you're gonna get a game. And hopefully you can run it without installing it on your hard disk. So this person made a README. Uh-oh, you know what? I broke it. I broke compatibility. So he tells how to use it. CD, include, and then advent. So we include this, and then we type advent. Okay, so it worked. Now we're running an old school tech. This is like on the Commodore 64, a text adventure. You are standing at the end of a road in a small brick building. Around you is forest. Let's go west. At a hill, you have walked up a hill. So this is, if you're an old person, you remember text adventures. This is kind of like, I don't know what to compare it to because I don't know any new games. So imagine it's a Myst or something, but it doesn't have graphics. West. I don't really play games, but this kind of makes me happy. So apparently, this is not just a text game, but a whole framework. And apparently, there are more than one game available with this framework. So I wanted to demonstrate how applications are going to work. So there's 2 things you need to know. You need to know how to access a CD-ROM, and I didn't explain that very well. It's kind of fucked. Maybe I should fix it. You know, it could just be me. As a matter of fact, that might be. Okay, so it figures out the CD-ROM when you're doing an install, so it is capable of identifying the CD-ROM. It has to check the first block, so maybe that's the problem. But anyway, you can ask yourself, okay, So I search for CD-ROMs. How do I know if it's the right one? Well, what you have to do is read the medium and say, is this me? I can't think of another way. So if you think it's bad doing normal scan, now imagine you have to figure out if it's you. So anyway, so there's two things you need to know. You need to know how to mount a CD-ROM, ISO, and you need to know how to mount a virtual disk. So this is necessary. If you buy the professional VMware, then you can mount a disk. The VMware costs $250. The free version will not allow this, then you say mount, and you go in you tell it which machine, TOS, VDMK. It's kind of tricky. You have to. It's the VMDK. Dyslexic. Now I define two FAT32 partitions. I do all of my accesses on the second, and the reason is because there are bugs. It's not really a bug. I don't support FAT32 fully, and it will get corrupted if you start accessing it from Linux. Just treat it as I have a C drive and a D drive. What I do is I copy everything to the D drive, and then I do all of my interactions on the D drive. And if it gets messed up, I just recopy from C to D. And anyway, so we have to have a mount point, and once we have a mount point, then then I can access it in VMware. It's pretty similar in Windows. So here's my mount point VM disk. So this is my these are my files. I can transfer in and out. Don't start renaming. Don't start. If you start, you can do the very minimum. Just copy in and out. Don't do any more. You start getting risky. What it is the problem is short file names. With FAT32, there's 2 directory entries. You start getting tilde. I don't mess with those tilde. If you remember the old DOS tildes for short names, I don't mess with that. And what we want to do is get VMware to support my file system, Red C, and we're going to get rid of all that fucked up crap. So hello? Hello? Good. Okay. No. Okay, so do I have a boyfriend? Wise guy or some shit. Anyway, so so we downloaded, and so here's the plan. We want to run like a Xbox. I don't really know what an Xbox, how it works, but I think it runs off of the CD-ROM. And so what we want to do is run off the CD-ROM, and we do not want libraries, okay? What we want is we just want the bare 100,000. Hello? Okay, bye. So we want the bare minimum, and so that's the plan. We want to run games from an ISO, and we don't want libraries. There's dependency hell once you start having libraries, and so I've been delusionally talking with Warren Buffett, and did he tell me I should get rid of my differential equation stuff? That's genius. Okay, so I should get rid of my differential equation stuff. So I got 600 lines of code for differential equations. Now look at that. Suddenly I'm in the fucked up situation everybody else is going to have. Okay, so I have several games which use the differential equation library, and so if I'm doing this kosher, then I'm going to put the game along with the redundant differential equation code. So if I'm going to be, because honestly nobody in the world is going to use this except me, because ain't nobody got time for that. I've learned, if there's one thing I've learned, it's people only scratch the surface, and so what I need to do, I'm really tempted to commit to this. I'm really tempted to commit to copying this redundantly into my application directories. This one uses it, this one uses it, this one uses it. I don't think this one does. So I have 3 that use it. That's that. Then I have some in my demo. This is kind of messed up. I'm going to have to start calling these applications. So basically at some point I start calling them an application. So this uses it. This uses it. This uses it. So I'm gonna have to make a redundant. If I'm being true to my word, I'm gonna have to start putting this into each one of these. This is not. I'm just. I'm not. We're not in the file manager. We're in the command line, and that's not doing anything. I'm just. I didn't want to confuse you so that you thought I was making a file operation. This is just. I'm not. Anyway. Now, if this example is not going to happen, there will be other cases just like this. And that's kind of how we're going to operate. It's more, I'm aware that we're going to start having a lot of redundant libraries, but that's how I want it. So what you're going to do is you're going to go to a website, you're going to download an ISO, you're going to come in, you're going to set it to your ISO. Then you're going to run it from the CD-ROM. And my applications, I have a policy. Actually, it's not an app. So I sort of lied. So some applications you put on your disk, and those go in the apps directory, I guess. Hopefully you run most of them off of the CD-ROM. But in either case, there will be an install that makes you want data files stored in your home directory. I think everybody understands that. So like my budget application has a directory in my home. So if you get a CD-ROM with a game, it might make a directory for saving games, and so that's kind of the vision. I think I'm going to stop right now, and that's what I wanted to show.